Hello, good morning students. How are you? I hope you will be good. All right. So let us, continue the topic further. So in the previous lecture, we were, taking the questions based on the principle of superposition of charges. So we will continue some more questions because this topic is very, very important. Okay, from all point of view. That is whether it is CBSE examination or any competitive examination. All right. So that today we can start with another question. Again, let us consider there is a square. All right. So question says like this: that there is a square of a certain side L. All right. And the charges, this square is A, B, C, D. This is a square each of side L. Now let's say that is plus Q charge is placed over here, plus Q charge is placed over here, and minus Q charge here and minus Q charge here. If you recall, in the previous class I took the charges at opposite vertices, okay, of the similar nature, that is positive positive or negative negative, but today I am taking different to clear the another concept. So now again we are asked, okay, to find the total force or net force at this point, where there are diagonals are bisecting. Okay, so we have to find out the total force at point O, which is having some charge capital Q. So this question is different. In the previous class I took the charges, okay, of similar nature at these vertices and the similar nature at these vertices. Then what was the total force at this point? It was 0. So I told you that trick, okay. In competitive examination you can easily put the answer, but it is different. So now the positive charge are here and negative charge here. So can we say, though the charge is same, that total force at O will be 0? Again, no. See why and how. So what we will see, as we have to find out the total force at O point, so we should know how many possible pairs of the forces are there. So the O will have the force with respect to charge at A, with respect to B, C and D. So there are 4 forces acting on it, okay. So we have to calculate them one by one. So when we talk about the force between A and O, so the charge here is positive, it is negative, okay. So what is the force of nature? That is the force of attraction. So the charge where force is to be calculated will be attracted, meaning thereby the force between A and O, right, will be pointing this way. All right. So can we find it out? Yes, we can find out, okay, because the charge is known here is Q small and here capital Q, and distance of course, because this is of L, this is of L, so hypotenuse or diagonal will be of how much? √2L. So half of that will be the distance. So you can find out first of all, that is AO is equal to BO is equal to CO and is equal to DO. All the distances will be equal, and what will be this distance? Are you getting my point? L is this is L, okay. So it will be √2L, and half of that will be this. Oh, so this will be √2L by 2, or you may simply say it is L upon √2. So this way we got the distance. So let us find out, that is the force between A and O. Because this positive is negative, so force of attraction. So that is the force is acting this way. Okay. So FOA, and if I just put it as let's say this is F1. So you can put it as, for the time being, F1. So this will be equal to K, Q at A, Q at O upon AO square. So what are the charges? So K as it is, QA is a small q, QO is capital Q, and upon AO square. So AO is this. So it will be L upon root 2 whole square. So finally how much it is? So this will become L square upon 2. So 2 will go up. So 2kq capital Q upon L square. So basically this is the first force, and that is along OA, this way, so you can put the direction as well along OA. Clear? So we got this one. So similarly we have to find out all the forces. So numerically I am telling you that is the all forces. The force here, here and here will be equal. Why? Because magnitude of the charges, capital Q, small q, capital Q, small q, capital Q, small q, capital Q, small q, all are same. Even distance also same. Okay. So but the direction is very important. Okay. So as for the magnitude of the four forces concerned, they are same. Now let us find out what is the direction or the nature of the force. So again it is positive charge Q and this negative force of attraction, and the point where force is being calculated should be attracted by the other. So we can put the sign of the force. This is the force. Okay, let me put it as F2. So you know that the magnitude is concerned, so F2 will be equal to F1 only, right? So but direction is this. Now think about C. So the force, nature of the force will be what? Is plus Q and this is plus Q. So force of repulsion. So the point charge where force is being calculated should be repelled by the other charge this. So it will be repelling this, meaning thereby the force of repulsion will again be acting this way, this. So let me put it as F3. Numerical value is the same. Now talk about this. Positive, force of repulsion. So you are finding out the force at this. So this point charge will be repelled. So meaning thereby the repulsive force will be this. So here it is F4. So don't you find it so interesting? Yeah. In the previous class, when the charges of similar nature, positive or negative, actually they were coming opposite, and they were equal also. They were nullifying each other at this, and this also. But do you find here the same logic? No. Rather, the two forces are pointing same direction here, that is F1 and F3, and F2 and F4 are pointing the same direction. So in any condition, okay, the total force will not come at 0. So we will have some force here, okay, resultant of this. So let me put that resultant of these two forces is F24, this way. We will add, because both of them are pointing same direction. Similarly, F1 and F3 are pointing same direction. So the resultant will be shown as F13. So we can find out. So that is the total force, that is F24, right, is nothing but F2 plus F4, because they are pointing in the same direction. So we will add, and numerically they are the same. So you will have 2k small q capital Q upon L square and plus 2k small q capital Q upon L square. Alright. So it will become, how much? So finally you are getting F24 is nothing but, 2k, so 2 or 2, 4. So this becomes 4 actually, okay? So 4kq upon L square. And what is the direction? So overall you can say it is acting from C to A. So you can put the direction as well, that is along CA. That's one. And now what is the resultant of these two? We will add them also. So as I am telling you again and again, that is magnitude of these two are same. So the total sum of these two forces will also be the same, right? So we can, this we have taken, sorry. So now we are taking this. That is the force F13 will also be the same. That is 4kq capital Q upon L square. So what should be the direction? Yeah, so we took, the 2, 4. So 2, 4 direction this, sorry. So this is a DB. So this will be along DB. And now this total will be along CA. So this is along CA. Alright. Now what is the resultant force? Should we add them directly algebraically? No, because the forces are not in the same direction as this way or that way, they are at these directions, meaning thereby they are acting at certain angle here. What will this angle? What is this angle? So you will see, that is they are, this was a square, so they are, at 90 degree. That is, these two forces are acting at certain angle. So how to find a resultant? So resultant you can find out by using a parallelogram law of vectors. Okay, so you will see the overall resultant will be acting somewhere else. Okay, so let's say this is the total force. So hence we can find out the resultant force will be equal to, by parallelogram law of vectors, that is F13 square, means this total force square, plus this, that is F24 square, to F13 into F24 into cos theta. And what is cos theta? It is cos 90, and cos 90 is how much? 0. So this term will be nullified. Fine. So you are having this, and incidentally these forces are same. Okay, so that is, you can say F13 square plus, either you can say F13 square, or maybe at both the places F24, and this term will become 0, because so this was total force, and this we have named as F1, F2, F3, F4, okay, all individual, but numerically since they were equal, so we can take them as F square plus F square. So this is a root 2 F square. So finally it will be root 2 times of the force, that is F total. Okay, so F total is coming this, and F was equal to this. So therefore final answer will be root 2 here, 2 Q small upon L square. So this will be the answer, but it's only magnitude. So because the question is for the force, so we need to show the direction. So you can say the direction of this resultant force will be acting vertically upward. Alright, or you can simply say that is AOB is the angle. So the direction is along the line bisecting this angle. So this way we can answer. Alright, so see here, I will write the direction. So because how to write the final answer is also important, because at least half mark is for answer. So please write down that is F total is coming as 2 root 2 K Q upon L square, and the direction is, right, what is the direction? So direction is along the line bisecting angle AOB. So this is actually the way to write the final answer. Clear? So I hope you have understood the difference. So always remember, whenever there is a numerical problem on the square, if the charges at opposite corners are of similar nature, right, and of equal magnitude, right, here, and these corners are also having the charges of similar nature and of same magnitude, then and only then the resultant force is 0. But if the sign are different, then it will not be 0. You will have some resultant, and we can solve the question in this manner. Clear? So this was one important question. So let's continue. I think it's clear. Sure. All right. So the another question I will take, again very important, okay, on the square again. So just to make you more comfortable in the numericals, where the directions are also important, that is vector concept is important, okay. So that's why I am taking more and more questions. So the new question says So I will make you more comfortable. Let's see. There is again a square. So question will say like this, see, that is A, B, C and D is a square, say of some side of 20 centimeter. Alright, now let's say some plus 5 microcoulomb charge is here, plus 5 microcoulomb charge is here, minus 5 microcoulomb charge is here, and again minus 5 microcoulomb charge at C. Alright, so we have to find out. Question will now say there is a square ABCD of side 20 centimeter with the charges placed on the 4 vertices like this. Okay, that is plus 5, minus 5, minus 5 and plus 5. Now I am not going to find out the force at the center point here. Okay, question says find the total force at D here. So question is now different. Very interesting. So please, very similar fundamentals. So what will be the first step? You will tell, sir, first of all we will find out how many possible pair of the forces will be there. So you will say the force at D. So this will have force with respect to A, with respect to B and with respect to C. So we identified there are 3 possible pair of forces. Alright, fine. So this will be at a distance like this. So very easily this is 20, 20. Okay, this will be 20 root 2. So no problem, you can find out 20 root 2 in centimeters. Of course we will convert into meters as well because that is the SI unit. So what is the next step then? So we identify 3 forces, one here, one here, one here. Now next point is nature. Positive, positive, force of repulsion. So the force of repulsion, whether this will repel this or this will repel this. So the point where force we are calculating should be repelled, meaning thereby it will repel like this. Okay, so the force will be acting this way. So let me put it as suppose F1. Please try to understand, very important. Positive, negative, force of attraction. So this should be attracted. Okay, so let me put it as F2. And again negative, positive, force of attraction. So again this point will be attracted. Okay, so let me put it as F3. So this way we are getting F1 this side, F2, F3. Clear? Yes. So as far as the numerical values are concerned, very easy. I have told you that distance is known, charge is known, distance known, charge known. Okay, we simply substitute the values, get the answer. Okay, so as I was I am sharing right from beginning, I am here to tell you the concepts, the numerical mathematics, that is multiple division. Probably you can do yourself just for a practice. So let me find out what is FAD. So FAD will be equal to, so write down the Coulomb's law, simple, K, Q at A, Q at D, and of course AD squared. Alright, so K as it is, and here it is 5 microcoulomb. So 5 means that is 5 into 10 to the power minus 6. Alright, and here is also 5 microcoulomb, 5 into 10 to the power minus 6 upon AD. AD is 20 centimeter. See, these are very simpler things. Okay, if you divide by 100 will become meters, that is 0.2. So it will be 0.2 square. Alright, so would you like to solve it? 5 5s are 25. Okay, rather you can use the term, K is 9 into 10 to the power 9, 5 5s are 25 and 10 to the power minus 12, and this will become 4 into 10 to the power minus 2 after doing the square. Okay, so how much it is? 25 into 9, 2, 2, 5, 10 to the power minus 3 upon 4 into 10 to the power minus 2. Alright, so you can just solve. 4 5s are 20, 6. So approximately this will be there. Okay, 10 by minus 3 and minus 2, so that is minus 1. So you will have 5.625, okay, newtons. And what is the direction? I told you this is along AD. So never forget to write the direction, okay, along AD. Okay. So that is FAD. Though I have just calculated for you, okay, this numerical value, but it is a matter, okay. You just need to understand the basic procedure, basic concepts, how to proceed. But anyway, we have calculated, okay. Please never mind if there are some mathematical, variations here and there, okay, because simple mathematics. All right. So we got FAD this way. Then we can find out this FDB, which is pointing this way. All right. So you will find FDB. So you will have K QD QB upon DB square. So DB square is 20 root 2. So instead of wasting time, definitely you will get some Newton, and direction is of course nothing but along DB. You get this answer. So let us put this is the first force, this is the second force, okay. Then what next? F3. So F3 will be numerically equal to this only, that is FAD. So as I have put already F1, okay. So basically this force was F1 and the second force is nothing but F2, and as I am sharing, the F3 numerically will be equal to nothing but F1, but direction is different. So therefore F3 will also be equal to F1 numerically, but the direction is along DC. Clear? Now what to do? What is the next step? Because these three forces are in three different directions and the force is a vector quantity. So we cannot add them algebraically. We have to add them vectorially, right? So how to add? There are three directions, 1, 2 and 3. So whenever there are number of directions, okay, so our idea should be all the forces or the vector term or the quantities should be made along x and y axis. So this is already along the positive x axis, this is the negative y axis, this is somewhere in the xy plane. So here we have to split. So see, very important thing. So to solve it, F2 is here and this is the square. So total angle was 90. So this angle will be 45 degrees. Fine. So let us resolve force F2. So when you resolve F2, you will see this will come as F2 cos 45 and one component will be here F1 sin 45. This F2 sin 45. So this way you have resolved, because this F2 was in xy plane, neither along x or no y, okay. So one component we got this side and other component we got this side, okay. So once you have resolved, so this force is now out, okay, because one of the component we are considering along this axis and one component we are taking along this axis, okay. So what is the new position now? New position is all forces are now, the two forces are along the positive x, one force along positive y, and one force is acting even in negative y direction. Clear? So we have to solve this. How to proceed? All right. See, so this is fine. So we can say the total force, that is Fx. Please consider this Fx. That is total force along the x-axis. So this will be summation of the two, because both of them are pointing same direction. So you will have F3 plus F2 cos 45. So please remember, instead of wasting time, please put the value of F3, F2 cos 45 is 1 upon root 2. So you will simplify it, okay. So can I put it as suppose x? So suppose this value comes as capital X numerically, you will get it. Similarly, let us find out what is Fy, that is the total force along the y axis, okay. So one force here and other force there, okay. So F1, right, and the F2, okay. So you have to see which is greater or smaller numerically, right. So I hope, because this component is having, that is 1 upon root 2, fine. So probably it will be less than this. So anyway, it is immaterial. Please remember, I am here to clear the concept again and again. I am focusing or emphasizing, okay. So F1 if greater than this, okay, so the resultant will be in the direction of the greater force. So this will be now F1 minus of F2 sine 45. And by chance if you find this F2 sine 45 is greater than this, no problem, you will say, sir, then resultant force along y-axis will be this minus this. Immaterial, but you will get some value, say y. Clear? So if I am in this opinion, that is F1 is greater than this, okay, so resultant force comes this. So overall picture is becoming like this, that is the total force along the f-axis which we are saying, say it is coming as x, and other force is coming along this axis, that is Fy, which is nothing but capital Y. So now we have to find out the resultant. So because these two forces, because actually it was the xy plane only here at this point, so one force this way, other force this way. So how to get the resultant? Again by using a law of parallelogram of vectors this way. So actually the resultant force will be this. So it is finally the Fr, that is F resultant. So therefore F resultant will be equal to parallelogram of vectors. So by chance these two forces are already at 90 degree. So you will finally get Fx square plus Fy square plus 2 Fx Fy and cos of 90. So this term becomes 0. So we are left with the total or resultant force will be equal to simply Fx square plus Fy square. Okay. And because we got this, their numerical value as x and y, so you can put it x square and y square. Let's say it comes as a z. So this is basically the final answer, that is Fr, that is resultant force at point D in this arrangement is equal to Z Newton. But direction again. So what is the direction? Resultant is this. So can we say, oh, along this? Yeah, of course we can put like this, okay? Suppose this was the D point, and let me put it as a suppose E point. So you may say it is along DE, but more scientifically it will be, you better to find out the angle, right? This angle. So the direction we can find out with the help of this. So actually to find the direction of this resultant force, you can simply say, sir, the direction can be calculated by tan theta. Tan theta perpendicular upon base. Perpendicular is exactly the vertical component, that is Fy upon Fx. Fy was y and this is x, numerical value we know, so therefore theta will be equal to tan inverse of y upon x. Yes. So this is basically the, so what is the final answer? We will say that resultant force at point D in this arrangement is Z Newton at an angle this with respect to the horizontal x-axis. This is the absolutely correct answer. Clear? So I hope till now, okay, everything will be clear, loud and clear, okay, and you may be enjoying this session. So I think I would like to take one more. There are many questions, so there is no end of some, good questions, but at least let me take one more. All right. Okay. So the question is, say there is a triangle. All right. Let me put it again, A, B and C. Right. And here is, some charge, 2 microcoulomb. Here it is say minus 3 microcoulomb, minus 3 microcoulomb. It's the equilateral triangle 20 centimeter each. Alright. So in this arrangement, okay, suppose I say find the net force at A. So in previous class we have taken, such question, okay, of a triangle. But the question is different now. That is, we have to find out the sign and magnitude of a third charge at some point M lying at the midpoint of BC. So meaning thereby like this. Okay, so we have to find out that is how much charge and of what nature should be placed at midpoint of BC so that the point A is in a state of equilibrium. Meaning thereby, because of B and C, A will have some force. So whatever will be that force, okay, it will be in certain direction. So we have to place a charge, right, such that a force between the A and M should become equal and opposite. That will be the solution. So first of all, we need to find out the total force at A due to BC, and we will come across what is the numerical value and what is the direction. So depend upon that, we will be placing some charge, say some unknown charge small q here, okay, right? And of course nature can be found out, because let me see what is the direction of the force. Accordingly we will answer what should be the nature of this charge, whether positive or negative. So initially let us put total force at A. So alright, when we need to find out the force at A, again number of pairs of forces, so this -3 microcoulomb charge will have some force here, similarly force due to this also. Negative, positive, force of attraction, total force here, so therefore it will be attracted, okay, so you can indicate. So F1 will be this way, similarly positive, negative, again force of attraction, that is F2. Let us find out. So therefore, have you understood the question please? Because understanding of the language of the question is very important. I am repeating once again for your convenience. The ABC is an equator triangle, each of side 20 centimeter. That is +2 microcoulomb, -3 microcoulomb, -3 microcoulomb are charges placed at the vertices ABC respectively. Find the nature and the nature of sign and magnitude of a third charge which is to be placed at the midpoint join on BC, so that the point A or the charge at point A, right, should be in the equilibrium position, meaning thereby the net force at this should be 0. So to make this A charge at or any equilibrium state, okay, we need to find out how much charge should be placed and what should be the nature of it. Is it positive or negative? So let's find out F1. It's easy. F1 will be equal to what? K QA QB upon AB square. Alright. So you can substitute, of course these are micro values. Micro means -6 and centimeter. Of course this become 0.2 in meters. Alright. So when you will substitute, as I was telling you, substitution you can do yourself also. As of now I can do 9 × 10⁻⁹, and this will become 2 × 10⁻⁻6, and here it is 3 × 10⁻⁻6, and again this become 0.2 whole square. So when you will simplify it, okay, this may come as 1.35 Newton. Similarly you will get the F2 as well. So even you will say the F2 will be equal to F1 is equal to 1.35 Newton. But no doubt the directions are different, okay. So you will please write down it is along AB and this is along AC, 1 and 2. Clear? So once these two for this way, okay, and because vectors hai, so therefore we need to find out the total resultant force, okay. So this is the angle between them. So resultant force will be by using the parallelogram vectors, okay, this way. So resultant will be acting this way. So let me put it as F, right, F, or rather resultant of these two you may put it as F12, because it is the resultant of 1 and 2. How much will be this angle? Being a equator triangle, it is 60 degree. Alright, let's proceed. So therefore F12, meaning the total force at A due to B and C is F1 square plus F2 square plus 2F1 F2 cos of 60. Alright, so when you do this, it is how much? Half. So, and these forces are equal, so easy. That is F square plus 2 F into 1 by 2. So 2 get cancelled, F square, so this will become root 3 of F. So that is root 3 and F was equal to this 1.35 Newton. So of course you will get some value of this. How much you will get? So you may get it as somewhere around 2.34 Newton. Whatever it is, mathematics you can do yourself. Alright. So the major question was that is the total force is this and in which direction? It is pointing downward. So to make it in equilibrium, that is to make this force zero or to nullify it, there should be some charge here such that the force between this small q charge and the charge at A, right, the force between these two should be equal and opposite. So numerically the force between AM should be equal to this F12, but opposite. When it will be opposite? When the force will be acting like this. So let me put it as FM, or rather FAM you can say. MA rather we must say. So one answer we are getting here to nullify this force. Because this charge is positive, so here the charge nature should be positive so that it will be repelling A. So that force due to this will be pointing upward, right? So once it is acting upward, okay, and that is downward, so they will nullify each other. So hence net force will be 0. But we have to find out the magnitude as well. So you found out, the nature of a small q at M. This should be positive. Only then it will be pointing upward to nullify the downward force at A. Then what should be magnitude? So you can simply say, sir, force between AM upward should be equal to the resultant of these two. Alright, and resultant of these two we know already this much. So you can put that is FMA should be equal to F12. Alright, FMA is equal to how much? K, Q at M, Q at A upon AM square is equal to F12, which you already got somewhere 2.34. It is 2.34. Alright, now what is AM? You can easily find out, okay? So let me just get it. See, there are mathematical calculations, so it takes longer time. So what is AM here? So you can use any one of the triangle. So you can easily find out. So AM will be equal to root of 20 square minus 10 square. So I think this will be 10 root 3. 300 minus 400 minus 100 is 300. Okay, like this. Or in meters it should be equal to 0.1 root 3. So you got this. Now let me just put it. K, QM, which we don't know, it's a small q. QA we know, that is 2 microcoulomb, okay. 2 micro means 10 to the minus 6. And AM we just got, this. So that is 0.1 root 3 whole square. And here this value is also known 2.34. And K of course value 9 into 9. So what is the unknown here? Only Q. So if you simplify this, you will get a small q, right? So just try to get it. How much? Got it? So probably when you will just simplify all these steps, okay? So this may come as 3.9 into 10 to the power minus 6 or simply 3.9 microcoulomb. Clear? So we got both the answers of this question, that what should be sign and the magnitude of the charge placed at midpoint on BC so that the A point is in stable equilibrium, or remains in equilibrium, that is no force. So the nature of the charge is positive and the magnitude is 3.9 microcoulomb. Alright, so these were the questions basically based on principle of superposition of charges, that is force between multiple charges. Okay, so we have covered a number of questions, right, using triangles and the squares. Similarly we can use the rectangle, etc. Okay, so please try to do the written practice of these questions. Okay, so I am sure you have understood each and every concept, and I have tried to make this concept very easy for you. Okay, thank you, have a nice day.